Hi, boys and girls. So I thought I'd offer a little help on sex-linked genes number 2. So this assignment, you're going to be in your interactive notebook on page 27. You need to pull up this assignment, sex-linked genes number 2. It's also on Google Classroom. So if you go in Classroom, you'll see it posted there for today. I'll pull it up so you can take a look at that. I don't have my tripod up and running, so what we're doing today, I'm going to have to do it on my phone by hand. Here's today's assignment. You can see it's posted there. And so in order to follow this, you'll need to click on that document and read off the questions as I go along. There's some things I'll be highlighting and going over. And so I'm going to do questions 9 and 10 together. And so if you have not done sex-linked genes number 1, you should back up and do that first. This will make more sense after you've done that assignment. Remember, when we say sex-linked genes, we're simply talking about the sex chromosomes, the X and the Y. Most of everything we do is going to be on the X chromosome, and most of everything I talk about is going to be recessive. That means it needs to have 2 of those X-linked alleles in order to show that trait. Keep in mind, males have 1 X, so they either have it or they don't. Females, on the other hand, have 2 X's, so they can be carriers. That means they can have 1 dominant, 1 recessive allele. So on sex-linked genes number 2, we started off with some notes, and we learned about color blindness last week. We learned about hemophilia as well. Today we're going to learn about eye color and fruit flies. And so just in the background, real quick, we took some brief notes. And so eye color in Drosophila melanogaster, that's just a fancy name for fruit flies, is also sex-linked. And so by that, red eyes are dominant to white eyes. So keep this in mind. There are a couple different outcomes. So a male that has red eyes, he is XRY. Remember, all males are XY, and we're notating that capital R is on the X chromosome. A male that has white eyes, we annotate that by writing X superscript lowercase r y. It once again shows that eye color is on the X chromosome. So male with red eyes is capital R, X capital R Y, and male with white eyes is X lowercase r y. And so females, however, are a little bit more complicated in that there's a couple options. So a female with red eyes, she could be homozygous dominant, X capital R, or she could be heterozygous, X capital R, and this is also capital X, by the way, they're not lowercase, X capital R, X lowercase r. So that's one option for a female with red eyes. A female with white eyes only has one option, X lowercase r, X lowercase r. So now we're going to answer 2 questions. In the first part, I hope my hand's not too shaky. We're going to go right through this in the background. Once again, you need to look at this document because it's not going to make much sense what I'm doing right here if you're not following along. So the first one, question number 9, I'm going to put my camera on my page now. And so it says, in men, defective eye color vision results from sex-linked recessive allele. A man and a woman. So we're going to make a precursor to a pedigree. And so here's number 9. And a man has XY for his genotype and XX. And this man is number 1. So he's the first individual in this pedigree. And the female he married or had union with is number 2. A man and a woman, both of normal vision, have the following 3 children. So the way we represent their offspring is we draw a line straight down. I'm going to draw a line over now because they had 3 kids. So, and by the way, these numbers would also be names if we knew who they were. Now they're just individuals. Had 3 children. So let's take a look here. All of whom are married to people with normal vision. That's important. So they had a colorblind son. He's number 3. So I'm going to start off over here. Here's the boy. He's XY. He's individual number 3. And he's colorblind. So I'm going to put an XC right next to him, if you can see that, okay? And they all married, remember, somebody of normal vision. So his wife is XX. Okay, that's number 3. And then we have number 4. Let's go across. Now it talks about who this man had. This man who has a daughter of normal vision, 6. So this guy, number 3, him and his wife, they had a daughter. She's XX, and she has normal vision. She's individual number 6. Okay. Then they had a daughter of normal vision. She's the second child. So I'm going to put this down right here. And girls are XX. She's number 4. And she married some guy. As they said, they all married somebody of normal vision. And then number 4, who has a colorblind son and 2 normal sons. So we're going to go back to them. And she's got one boy who is colorblind, XY. So I'll put a C next to him. And the colorblind son, was number 7. I'm going to label him number 7 on this pedigree. And 2 normal sons. So I'll break this down, XY. And the other XY. And those sons here, the 2 normal sons, are going to be numbers 8. Both of them are going to be number 8s. Okay, so once again, hopefully you can see that. This is the colorblind son right here. And this is the colorblind father, number 3, or the son from the parents. And then we have one more child to look at here. And so, and a daughter of normal vision. She's number 5. She's the 3rd child. So draw this line over. Sorry for the shaky hands. Here's the daughter, XX, XX, and she's number 4. No, hold on a second. She is number 5. My apologies. She's number 5. And she married somebody. Okay, XY. And let's take a look. Who has 6 normal sons? 6 normal sons. So we're just going to make that pedigree. I'm going to move this over to get more space here. XY, XY. Do that 6 times. Hopefully I can fit it all in there. 2, 3, 4, 5, and one more. X, Y. And so that's all of them right there. All the X, Ys. And all those boys together, they're going to be group number 9. So here's all the individuals in that pedigree, starting with the man and the woman having 3 kids. They have a boy who's colorblind, XCY, a daughter of normal vision, XX, and another daughter of normal vision, XX, who married somebody. They all married somebody of normal vision. She had 6 sons. Individual 4 had 3 sons, 1 colorblind. And then individual number 3, this boy had a daughter of normal vision. He's colorblind. So now we're going to work backwards, and I'm going to start at individual number 3. So remember, dads give their X chromosome to their daughters. And so mom only has X to give. So a dad, in order to have a girl, gives an X chromosome. If he had a son, he gives a Y chromosome. So this X up top is going to come down and go here. So the daughter is going to be XCX. She's got normal vision, and she gets one of those X chromosomes for dad, which means she's a carrier. Now we're going to take a look at individual number 7 and work backwards from here. So here's a boy, and he got his X chromosome from mom. Remember, dads give Ys, moms give X's. So we're going to trace this back. This X chromosome came from his mother. She must be XCX. And we know all the couples, married people of normal vision, this man does not carry any XC chromosomes on him because they're all normal vision. We know this lady over here has normal vision. She could be a carrier, but we don't know. And we know this man over here, he is not a carrier because, once again, the woman number 5, married everyone of normal vision, and he has only one X. So now let's take a look here. Here is one daughter, individual number 4, and one son here at number 3. And he is colorblind and she's a carrier. Well, he is kind of a giveaway Because he gets his X chromosome from mom. We're going to trace that back up. So he got this X chromosome from her, individual number 2. So she is a carrier for colorblindness. Dad has normal vision, like it says. Number 1, a man and a woman, both of normal vision. So dad is normal XY. Mom is a carrier. She's XCX. And you can see where he got the XC chromosome from mom, which also she gave it to individual 4 as well. Okay? And so that's how we do the background here on question number 9 for these pedigrees. Those are the pedigrees and the genotypes, of all those individuals. Person number 9 down here, all of those boys are normal. And the woman over here could possibly be a carrier, but it doesn't seem likely because she had 6 boys, none of which are colorblind. So more than likely her genotype is just XX. And then the final help I have for today is question number 10. And this is exactly from the notes. So please make sure you look at the notes for today. And so this once again goes to fruit flies. And remember, males are either red with X capital. Okay, so the final question we'll work on today as an example is question number 10. And so this, remember, comes from the notes where we know that red eyes for males are X capital RY. White eyes for males are going to be X lowercase ry. Females have 2 options, X capital R, or X capital R, X lowercase r. For wide-eye females, they're always X lowercase r, X lowercase r. And those are superscripts. So we're going to get started here. And this is questions 10, 11, 12. They're all Punnett squares. So it says in fruit flies, they go through the background. Eye color is carried in the X chromosome. The allele for red eyes is dominant over recessive allele for white eyes. Here's what it tells us to do. Cross a homozygous red-eye female to a white-eyed male. So there's only one option for that. Here, I'm going to draw the Punnett square. And so females go on the side, and males go on top. And so it says homozygous red-eye female. Remember, homozygous, that means the same. So she's going to be X, capital R, X, capital R. To a white-eyed male. Only one option there, X, lowercase r, Y. Now, we just do the Punnett square and put those letters in the boxes. So we have here X, capital R, X, lowercase r. X, capital R, X, lowercase r. Over here, X, capital R, bring the Y down, and then X, capital R, bring the Y down. Now we have some questions A through H, but they're really simple and they're really quick to answer. So A, B, C, D, E, F, G, and H. I'm going to label them on my paper. And so it says, what's the genotype of the male? The male, it said he was white eye, so he's got to be X, lowercase r, Y, just like that. Next question, what's the genotype of the female? The female involved in this cross was homozygous red eye. She's X, capital R, X, capital R. There you have it, just answering those ones. C, it says, how many genotypes are possible among the offspring? If you look here, there's only 2. X, capital R, X, lowercase r, and X, capital R, Y. These are the same, and these are the same. So there's only 2 different types of genotypes possible. And this is question C. So I have to make sure my lines are straight, but there you have it. And then D, how many phenotypes are possible among the offspring? Those are only 2. Remember, genotypes are the genetic code, the letter. Phenotypes, the physical appearance. So for that D, we have red-eyed girls and red-eyed boy. Those are flies we're talking about, of course. E, what's the probability of the offspring that are red-eyed males? There's 2 ways we can look at this. there's a 50% chance having a boy, and all the boys will be red-eyed males. So I'm going to say 50%. That's what it's going to be, because it's just 50% chance having a girl, 50% chance having a boy. All the boys will be red eyes, and all the girls will be red eyes. So then, F, what's the probability of having offspring that's white-eyed male? That's 0%. None of the males are white-eyed. Let's take a look at G. What's the probability of giving offspring that are red-eyed females? That's going to be 50%. Once again, boy or girl are going to be 50% chance of red. 50% chance having a girl, 50% chance having a boy. And the only option in this cross is red eyes. And the last one, what's the probability of getting offspring that are white-eyed females? None of those females are white-eyed, so that's 0%. And so that's how we do a Punnett square using eye color and flies and fruit flies. Don't let those overwhelm you. If you have any questions, just let me know, but just give it your best. Questions 11, 12, use the same method in doing those Punnett squares.